Okay, we've come to the last type of equation that we're going to solve is the radical equation, and we're going to use only square root or cube root, how to solve equations with square root and cube root. So one strategy is to isolate the radical. What do we mean by that? So for number one, the given is square root of x minus 4 minus 10 should equal to, okay, so you see that radical is not isolated because it's together with the minus 10. That's what we mean. Okay, when we say isolate the radical, we should move this to the other side. Okay, so let's move. So this will be x minus 4 should equal to plus 10. Continuing, so that will be x minus 4 is equal to 12. When you reach this part that they are now isolated, that your radical is isolated and this is, okay, a number, all you do is you square both sides, right? Okay, what you do on the right, you do on the left. So that square will remove this square root. Because if you square and then you get the square root, okay, what remains will be the radicand. No more square root, no more square. So this will be 12 times 12 is 144. And then this becomes linear now. So x is just equal to 148. Okay, so if you like to check on that, we could check. Let's check here on the side. So square root of 148 minus 4 minus 10, is that really equal to 2? Okay, let's see. So this will be square root of 144 minus 10 is equal to 2. 144 square root is 12. So 2 is equal to 2. Check. Okay. Let's go to number 2. So cube root. So now we're doing cube root. 3x minus 1 over 2 is equal to 1. So again, we have to isolate the radical. Okay, we have to remove this over 2. And that is easily done by multiplying both sides by 2. So this will be cube root of 3x minus 1. Okay, let's multiply by 2 both sides to remove that 2 there. Okay, that cancels out. So that will just be equal to 2. How do we get rid of a cube root? Pause and think about it. Okay, so we raise it to the third power, both sides. So when we raise that to the third power, there is no more cube root. So this will just be 3x minus 1 is equal to 8. 2 to the third is 8. Again, this is now linear. 8 plus 1 is 9 divided by 3, x equals 3. Okay. And you can always check. Next. Okay, number 3. We have square root of 2x minus 1 should equal square root of 3x plus 5. Okay, so if they are both square root, okay, they are both isolated. Okay, one is here and one is there. So to get rid of the square root, you just square both sides. Okay, then that removes the square root. So you are now left with the radicand here and equal to the radicand there. Again, that is now linear. So you just solve that. 2x minus 3x is equal to 5 plus 1. So negative x equals 6. Divide by negative 1 both sides. X is equal to negative 6. Now you always check for extraneous roots, meaning to say if upon substituting this here, you will get a negative number inside. Remember, there is no square root of negative number. Then you will say still no solution. If you get a square root of a negative 1, a square root of a negative number, that is I. So you are not going to consider that. So let's check here. Let's hope we are not going to get a negative number, a negative radicand. 2 to the negative 6 minus 1. Okay, oh, that's already negative. That is square root of negative 13. That's not possible. That's square root of 13i. But let's just continue. On the other side, you will also get 3 negative 6 plus 5. So you will also get square root of negative 13. Although they are equal, but you got a square root of a negative 13. These are imaginary numbers. It's not real. So you will still not consider them your solution. You will still not consider them as the x negative 6 as solution. So although you got an answer here, you will still conclude that there will be no solution. Okay, that's the final answer. No solution or no real solution. That's even better. Okay, so again, when you have a square root, it should always be positive inside. Cube root, you can get negative radicand for cube root because there is a cube root of a negative number. Okay, I hope you got that. Try to do the numbers again. Look at the transcript and solve them again on your own.